So now let's talk about, like in my previous video I have talked about azimuthal quantum number and why it is known as angular momentum quantum number. If you haven't watched my previous video, kindly watch that video and then come to this video. So now let's talk about magnetic quantum number. It is also known as orbital orientation quantum number. So magnetic quantum number is also known as orbital orientation quantum number. So what does this magnetic quantum number actually shows? So it shows you the orientation of orbital. Orientation means the region, like in which axis, like we are having three axes, x, y and z. So it shows you the orientation of the orbital. So the formula for n, like we talk about this later, L and M, right? The formula for finding magnetic quantum number is -1, 0, +1, right? So we know that in L, the first subshell is S, so the magnetic quantum number will be 0. So in second L is 1, which is P actually. So 1 minus 1, 0 plus 1, right? Second is 2, which is D. So -2, -1, 0, +1 and +2. Okay. Now we are having 3, which is F. -3, -2, -1, 0, +1, +2 and +3. So what does these show? So these are the orientations. These were like N is shell, L is subshell, these are orbital. Now this is the exact probable location of an electron. Like here the electron is present here. This is having only 1, it is having only 3, it is having 5 orbital, 1, 2, 3, 4, 5, and it is having 7, 2, 3, 4, 5, 6, 7, right? So what it is showing you that M is equals to orbital, like in S only one orbital is there, only one, and in P there are 3 orbitals, 3 degenerate orbitals. Now what does it mean, degenerate? Degenerate means having equal energy. These 3 orbitals are having equal energy. Now we are having D, it is having 5, 1, 2, 3, 4, 5 degenerate orbitals, right? F, it is having 7 degenerate orbitals, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, okay, having 7 degenerate orbital. So it tells you that how many orbital will come in a subshell. So for finding that how many orbital will come in a shell, we are having the formula n square, right? If you want to find that how many orbitals in a shell, so you will put formula n square. If someone is asking that how many orbitals are there in number 2 shell, so 2 to the 4, so there will be 4 orbitals in shell number 2. But if you want to find that how many orbitals will be in subshell 2, which is P, so in P how many orbitals will be there? So what is the formula 2l plus 1. So this is formula where L is the azimuthal quantum number, right? So 2, the azimuthal quantum number of P is 1. So 2, 1 plus 1. 2 ones are 2 plus 3. So 3. And we know that here in P there are 3 orbitals, right? So for finding how many orbitals will be there in a shell, so the formula is n square. But how many orbitals are there in a subshell? So we are having formula 2l plus 1. So now let's find out. We are having a shell, n is equal to n l m, right? So for example, I'm having shell number 1. So how many L will come here? Only 0. S will come. Magnetic number will be also 0. If I'm having shell number 2, right? So how many L will come? Over here, 0 and 1. Right? Here 0, minus 1, 0, plus 1. If you are wondering that how we will know that how many subshell will come in a orbit, in a shell, so we were having a formula which is n 1 n minus 1. So this was the formula for finding how many subshells will come in a shell. So you can see that in shell number 2 there are 2 subshells and there are total 4 orbitals, right? If you are having shell number 3, so 0, 1 and 2, right? So 0, minus 1, 0, plus 1, minus 2, minus 1, 0, 1 and 2. So how many subshells are here? 1, 2, 3. How many orbitals are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9. If I am saying that we are talking about shell number 4, so 0, 1, 2, 3, right? So here 0, minus 2, minus 1, 0, plus 1 and plus 2. Here 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. So how many suborbitals are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 orbitals in shell number 4. Talk about, yeah. So now if I want to ask you that how many orbitals are there in shell number 3. Okay, you will count here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here 9, you will say 9. So there is a simple trick, a simple formula, like if I want to know that how many orbitals are there in a orbit. So the formula is n square. Like we were previously we were done about 3. Now 3 square is equals to 9. So you can easily find that there are 9 orbitals in shell number 3. Okay, and now if I want to find that how many orbitals will be there in a subshell, like subshell, I want to know that D. Okay, D. So the assigned azimuthal quantum number to D is 2, right? So what I will do, 2l plus 1. This is the formula for finding orbitals in a given suborbit. So L is equals to 2 plus 2 plus 1. 2 to the 4. 4 plus 1 is equals to 5. So you can easily find that how many orbitals will come in a subshell which is D. So this is a simple trick. By not doing this long process, you can easily apply this formula n square and 2l plus 1. Like if you want to know that how many electrons are there in a given orbital, a given subshell. For example, I'm having here S. Wait a minute. Yeah, having a S. So how many electrons are there in this? So formula for finding it 2l plus 1. So here L is azimuthal quantum number. So how many what's the azimuthal quantum number assigned to S, which is 0, right? 2, 0 plus 1. To 2 0 0 plus 1, 1, 2 multiplied by 2. So 2. So number of electrons in S orbital is 2. Now talking about P. So the assigned azimuthal quantum number to P is 1. So we are having formula 2, 2L plus 1, right? 2, 2, 1 plus 1. 2 ones are 2 plus 3. 2 ones are 2 plus 1, 3. 3 twos are 6. So there will be 6 electrons in a given suborbit. Now talking about D. Now D 2L plus 1. So L, the assigned azimuthal quantum number to D is 2, right? 2, 2, 2 plus 1. 2 to the 4. 4 plus 1 is equals to 5. 5 multiplied by 2 is equals to 10. So there will be 10 electrons in a suborbit D. Now talk about F. Right? Now the 2L plus 1, right? Now the azimuthal quantum number assigned to F is 3, right? 2, 2, 3 plus 1. 3 ones are 3, 3 2 are 6, 6 plus 1 7, 7 multiplied by 2 is equals to 14. So there are 14 electrons in a orbit in a subshell. Now let's look. S2, P6, D10, F14. You have to remember this by giving, you can easily remember this by these formula. So now how many formulas we have learned? Like for finding the magnetic quantum number, which is -1, for finding the how many subshell will come in a shell, N1, this is formula, okay? Or for finding that how many orbitals will come in a shell, so it is N square. Now how many orbitals will come in a subshell, which is 2L plus 1. Now how many electrons will come in a subshell? We are having formula 2L plus 1, where L is your azimuthal quantum number. So I hope that you have understood the concept of magnetic quantum number.